Okay, so another type of transformation is called a dilation. A dilation makes the graph narrower than the parent function or wider than the parent function. When the parent function x squared is multiplied by a constant, the resulting graph, which is ax squared, is either stretched or compressed vertically. Okay, now here's how it works. It's a little bit tricky, but here's how it works. If a is bigger than 1, then it's stretched, okay? So I like to think about it like this. If it's 2x squared, like this, it's going to be twice what x squared was, so it's going to stretch it up. You know, if you're 2 times as tall as somebody else, you're stretched out a lot taller than they are, so the graph's going to be taller, okay? If a is between 0 and 1, like say a quarter, okay, it's a fraction less than 1, okay? Then it's going to compress it, it's going to shrink it because it's a quarter of the size, so it's going to smash it down a little bit, okay? Don't get confused though, not all fractions are compressions. If you had 8/7 x squared, 8/7 is bigger than 1, so therefore it's going to be stretched by a factor of 8/7, okay? So here we go. Describe how the graph of each function is related to the graph of x squared. This first one, you're multiplying by half, which is a number, which is a fraction between 0 and 1. So it's a dilation that is compressed vertically. So here's the original graph in blue, and it smashes down the graph of that to make the green graph. So it looks like it actually spreads it out a little bit. Okay, it's kind of what it ends up looking like. Okay. B, did you notice that there are 2 different transformations here? You're multiplying by 3 and add 2. Okay, so the 3 is bigger than 1, so it's going to be 3 times as big, so it's going to like stretch it up, okay, or squish it up. And then the +2 moves everything up 2 units, okay? Now, a question comes up when we start getting more than one transformation going on. And like this one, we have a dilation and a translation. Okay, so the question starts to come up, well, which one do I do first? Here's the easiest way to think about it. If you put a number in for x, what would you do to it? You'd square it, then you'd multiply it by 3. So do that one first, then you'd add 2, so do that one next. Okay? So I would think of it as being stretched vertically and then shifted up. Okay, not shifted up and then stretched. Okay, just like follow order of operations kind of thing. All right, so go ahead and try these 2. 3. All right, we're back. So this one, here's the graph of x squared. And then 2x is going to compress it or stretch it vertically, rather, not compress. Okay. 4b is going to be stretched vertically by a factor of 5 and then shifted down 2 units. So here's x squared, and then it's going to be stretched up. 1/3 x squared plus 2. Here's x squared. 1/3 is going to squish it out, kind of, and shift it up 2 units. Okay? All right, a reflection flips a graph across a line. Okay, so if the negative is outside of the parentheses, it just flips it over the x-axis. If the negative is inside the parentheses, it flips it over the y-axis. Okay? So watch these ones. So if I have negative 2x squared minus 3, I actually have 3 things going on there. If you plug in x squared, if you plug in a number for x squared, you'd square it. Then you'd multiply it by 2, which would stretch it vertically. Then you'd have the negative of that, which would flip it over the x-axis. Then you'd subtract 3, which would shift it down 3 units. Okay? So see how it's flipped over, shifted down 3 units, and stretched vertically. Okay? This one, you actually have 4 things going on here. You're adding inside the parentheses, which is going to shift it 2 units to the left. You're multiplying by 4, which is going to stretch it vertically by a factor of 4, and the negative flips it over. then you're going to move everything up 1 unit. Okay, so we got a lot going on there, so just keep track of it. Now, again, which ones do you do first? Well, since if you plugged in a number for x and followed the order of operations, you would add 2 first, so you shift it. So if it starts here, you'd shift it 2 units to the left, then you'd stretch it vertically and flip it over like this, and then shift it up 1 unit, so it would end up being there. Okay? So here's what the graph looks like. Here's the original graph. It shifted 2 units to the left, flipped over, stretched vertically, flipped over, and then shifted up 1 unit. Okay? All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. Now, this one, where you have the negative for the x, since the parabola is a reflection or is symmetric with respect to the y-axis, when you flip it over the y-axis, it just lands on itself. Okay? Then it's going to be stretched vertically by a factor of 2 and shifted down 9 units. Okay. All right. This one, there's no negatives, so it's compressed vertically by a factor of 1/5 and then shifted up 3 units. So here's the original graph. Compressed vertically by a factor of 1/5 would make it like that, but then you have to shift that whole thing up 5 units. Okay, so it's like a really flat parabola. Okay. This one got a lot of stuff going on. We're going to move it to the left 1 unit. We're going to stretch it by a factor of 2. We're going to flip it and then go down 2 units. Okay, so here's the original graph of x squared. We're going to shift it. Excuse me, I said to the left 1 unit. It's to the right because it's subtraction by 1. So 1 unit. Stretch it vertically by a factor of 2, flip it over, and then move it down 2 units like this. Okay, so I would just regraph it right there like that. Okay? Alrighty dighty. You can use what you know about the characteristics of graphs of quadratic equations to make an equation with a graph. What on earth does that mean? Which is an equation for the function shown in this graph right here. Okay, couple things you already know. You already know it's flipped over, and you know it's shifted up 1, 2, 3, 4, 5 units. Okay? So if you had a multiple choice problem like this, you know that you'd want to pick the one that has a negative in front of the x squared, because it's flipped over, and adding 5 outside of the parentheses. Okay? So since you have 4 choices here, we can eliminate some of them. So you're given the graph, you need to find its equation. The graph opens downward, so the x squared has been reflected across the x-axis, and the leading coefficient should be negative. So we can cross off those 2 because those 2 would open upward because their leading coefficients are positive. Also, you know the graph has been shifted up 5 units, so you know you have to add 5 to the x squared, which would eliminate choice B. So the only one that's possible is choice C, -1/2 x squared plus 5. Okay? All right, here's one for you to try. Identify the graph for which y equals -3x squared plus 1. Go ahead and pause the video. Okay, we're back. So couple things, you know it's flipped over because there's a negative, so you can automatically take off F and J. And the +1 means it's shifted up 1 unit. This one shifted up 2, this one shifted up only 1, so the correct choice would be H. Pretty cool, huh? All right, last thing we want to talk about is vertex form. A quadratic function written in the form a times the quantity x minus h squared plus k is said to be in what's called vertex form. Transformations of parent graphs are easily found from an equation in vertex form, okay, because the minus h and the plus k tell you where to put the vertex of the parabola. So basically, if, like, for example, if I had f of x equals negative 1/3 x minus 2 plus 6, forgot the squared there, I know that I would take the graph of x squared and shift it 2 units to the right and 6 units down, right here. Well, what's that point? That point is 2, negative 6. I'm sorry. Not 2 units down. 6 units up, rather. What's that point? That point is 2, 6. Well, that turns out that it's going to be the vertex of the parabola. Now, it's going to be flipped over and compressed vertically by a factor of 1/3. So it's going to look kind of like that. All right. But just by doing the vertical and horizontal translations, I can pick off the vertex. Okay. So if you just think about where the vertex would be, then you can get the vertex as long as it's in vertex form. So during a fireworks show, the height h in meters of a specific rocket after t seconds can be modeled by that equation. Graph the function. How is it related to x squared? Okay. Well, on a calculator, we can graph it, and I'll show you how to do that right now. So if you bust out your TI-83, let it load up. You plug in, so turn it on, clear that off, go to the y equals menu. If anything's there, clear it off. If any of these plots are ever highlighted, like that one, like that, turn it off. All you do is up and over until you get to it, hit enter, and it turns it off. So put in negative 4.6 parentheses. Now you can't use t, like don't go down here and find the alphabet letter t, which is 4. Don't use that. Always use x as your variable. X minus 3. Now you can either hit the x squared button or do the caret squared. Either one will work. Plus 75. Now if I do my traditional zoom 6, which is a standard viewing window, you're not going to see too much. It does not look at all like this one. Why not? Well, if you look at it, the graph, oops, messed up my iPad there. The graph is going to be shifted 3 units to the right and 75 units up, and flipped over. So I know that it has to go up to 75. So what I could do is change the window to go to, say, 80. Okay, and then I'll see more of the graph, and it kind of looks a little bit more like this. They adjusted it also. They went, they changed the window to go from -2 on the x-axis to 10. And they made this scaling, this x scale stands for how often they're going to put the tick mark, so every 1. Then the y, they went from -2 to 85. And in this one, they put a tick mark every 15 units. You don't have to get that crazy about it. But using the vertex and whether it's flipped over or not will help you a lot in determining what window to use to graph the function. Okay? So we answered some of the questions that they want us to answer. So 4 separate transformations are occurring in this one. So the negative sign is going to flip it over. The dilation of 4.6 stretches it vertically. It goes up 75 units and to the right 3 units. Again, I know in the book they list them in this order, but I'm telling you that it's easiest to think of them in terms of order of operations if you plugged in a number for t. If you plugged in a number for t, the first thing you would do is subtract 3. So I would move it to the right 3 units. Then you'd square it, which is just, you know, the squaring function that makes it a quadratic. Then you multiply by -4.6, which would stretch it vertically by a factor of 4.6 and flip it over the y-axis. Then shift everything up 75 units. Okay? All right, the St. Louis arch resembles a quadratic and can be modeled by that function. Graph the function. How is it related to the graph of x squared? Well, I will tell you that there are three. Oh, go ahead and pause the video. Okay, we're back. I will tell you there are three separate transformations going on here. Plug in a number for x, you would first square it, so it's not moving to the left or right at all, okay, because there's nothing added or subtracted in parentheses. Next thing you would do is multiply it by 2 over 315, which would compress it vertically. Then the -1 flips it over, and then plus 630 shifts it up. So if I have -2 over 315 times x squared plus 630, delete off that last little one, zoom 6, you're going to get probably not too much in there, okay? But I know that the vertex would be at, I'd have to go up 630. So if I make my thing go up to 630, I'm going to make my scales go by 50s. Let's see if I get anything there. Oops. I wanted my y max to be 630. But that mistake actually helped me out because I got to see where it fell over here. Okay, so I know that the other one's going to be over here. So since my x max went out to 630, I'm going to make my x min go to -630. And then graph that. And you could see the whole St. Louis arch right there. Now let me go back to zoom 6. That gives you the standard viewing window. And if nothing shows up, that means that, because it goes from -10 to 10 on the x and -10 to 10 on the y, that means that the graph doesn't show up in that portion. If you go zoom fit, sometimes zoom fit works. It doesn't always work. But usually zoom fit tries to get the x-intercept and the y-intercepts. Okay, and then you can go back to the window to see how they adjusted the window settings. Okay? All right, guys, that's it for this section. Please continue on to your assignment, and as always, reach out if you have any help. Take care.